We're going to talk about graphs of systems of linear equations. So I want you to just think about what is a linear equation in general. We know that forms the graph of a line, but now we're talking about a system of lines. So what is a system of linear equations? A system of equations is a set or collection of equations that you deal with all together at once. Simply put, you're going to take two or more equations and graph them together, all on the coordinate plane. You can find the solution to a system by identifying the point where the lines intersect. For example, if you look at this graph here to the right, you will see the two lines intersect at this point right here. The ordered pair of that point is 4, -1. So the solution to this system is 4, -1. Systems of linear equations are used in supply and demand situations to help businesses determine what price and quantity they should set for items before they sell them. Let's take a look at some situations where we use systems to solve problems. In problem number 1, we are posed with the question, at how many minutes do both companies charge the same amount? I want you to take a look at the graph for a second and just analyze it. Do you notice anything about company S's line and company Z's line? If we take a look at the graph, we'll look and see that these two lines do have a point of intersection. They meet right here at this point that I'm highlighting orange. At that point, we know that X is 10 and our Y value is 20. So the solution to this system, or the amount of minutes that both companies charge the same amount, is this X value of 10. So 10 minutes, and we could even go further and answer the question, how much money do they charge when they charge the same amount? And it is $20. So this is $20. Okay, so we could even go further with that. Let's take a look at another system and see if you can find the solution this time. Keep in mind, the solution is where the two lines intersect, where they meet. At how many minutes do both companies charge the same amount? I hope you notice what I noticed, which is that these two lines will never actually intersect. They're parallel lines, and parallel lines will never actually touch. And because that's the case, there is no solution to this system. So if we were to answer this question, at how many minutes do both companies charge the same amount? They never charge the same amount. So we would answer this question, they never charge the same amount. So anytime we see parallel lines as a system of equations, we know there is no solution to that system. Let's look at one more example before you jump into some yourself. Let's identify the solution to this system before we answer the question. What is the solution to this system of equations? Write it as an ordered pair. So when we look, we're looking for the point of intersection. These two lines do have a point of intersection right here. Okay, my X value here is 20. My Y value is also 20. It says at how many minutes do both companies charge the same amount. So if we're looking for where both companies charge the same amount and we're looking for minutes, minutes is down here on the X-axis. So again, we're going to look down and we can see it's 20 minutes. So the answer to the question is at 20 minutes. The companies charge the same amount. Now, let's have you try some on your own. For each graph on the next slide, you're going to list the solution as an ordered pair. If the system has no solution, I want you to write no solution. So go ahead and take 2 minutes. I want you to pause the video, and I want you to take 2 minutes to answer the questions on the next screen. So now that you've answered the 5 questions, let's check our answers. If we take a look at graph 1, our point of intersection exists right here. The x value is -2 and the y value is 0. So the solution to the system is -2, 0. On graph 2, the point of intersection is right here. The x value is -1. The y value is 3. The solution is -1, 3. In graph 3, there is no point of intersection. So I hope you knew to write no solution here. Give yourself a pat on the back if you got that. In graph 4, we do have a point of intersection. We can see that our x value is 2 and our y value is also 2. In graph 5, we can see that we do have a point of intersection. Our x value is 1. Our y value is -3, so our solution is 1, -3. Okay, so if you have any trouble with that, you can go back, press rewind, take a look at the video again, just to help yourself understand that a little bit better. Couple of key takeaways, and I do want you to write this down in your notebooks so that you have it ready for class when we come together tomorrow to talk about this further. Number 1, systems of equations involve 2 or more equations. Okay, in this case we are dealing with linear equations. There are other types of systems, but we know our focus is on linear equations, those lines. Number 2, the solution to a system is any point where the lines intersect, if at all. We've seen cases where they do not intersect. When they do, write that solution as x, y. Number 3, the system has no solution if the lines never intersect. Just really want to drive that point home. If they never actually touch each other, there is no solution to that system. And number 4, which we're going to delve into a lot more over the upcoming weeks, systems are used by businesses to determine supply and demand for their products. This helps them determine their cost and revenue before selling. So we're going to look at some real world situations, not just cell phone plans, but also costs of products. What should we charge? How many should we make if we want to meet this supply equation and this demand equation? And so we're going to look at that tomorrow, the day after that, and a couple of lessons following. Look forward to seeing you in class tomorrow. Have a great evening.